Hi all. So today we are going to solve this problem, maximize the distance between points on a square. So in the question you are given an integer side representing the edge length of a square with corners at 0, 0, 0, comma side, side 0 and side on a Cartesian plane. You are also given a positive integer k and a 2D integer array points where points of I represents the coordinate of a point lying on the boundary of the square. You need to select k elements among points such that the minimum Manhattan distance between any two points is maximized. Return the maximum possible minimum Manhattan distance between the selected k points. The Manhattan distance between two cells is given as the distance in between their x and y coordinates. Right? So you have to find out the maximum of the minimum distance, Manhattan distance between any two points when they are maximized. So and also in the constraints, if you see, there are some things like the points are more than 4 and the value of k is between 4 to this minimum of points length or 25. So let me walk you through this example and we'll try to conclude few things, few observations and see what intuition we can get out of it. Yeah. So in the second example, you would see that you are given a square. You are given a square, and the points are 0, 0. This is 2, comma 0. Then 2, comma 1, 2, comma 2. This is 1, comma 2. Right. So you have to find out the minimum distance. You have to maximize these distances between the points such that the minimum distance between any two points is would be your answer, right? And your answer is distance. And such that you should be able to select k points. Okay, so in the second question you are given k as 4, so you have to select 4 points. What is the minimum distance that you would get if we try to find out? So if we select this point, this point, this point, so we have selected only 3 points here, right? So the distance we see is 2 here between these 2 points. But if as soon as we go and select the fourth point, we have to either choose from this point or this point. Then the maximum distance the will minimized will come. The smallest is this one, right? 1. So the minimum of the maximum distance will become as 1. And whenever you are given such questions like maximum of minimum or minimum of maximum, the first thing that should come in your mind is binary search. And so few observations here, like k is given as 4, right? So the minimum value in the constraint also for k is more than 4, more than equal to 4 or less than equal to 25 or whatever the value was, right? So more than 4 means you are always given 4 points, right? More than 4 points maybe or 4 points. So in that cases, if you try to maximize the distance between them, so then you would try to put it in corner or maybe at the midpoint of these such that the distance between any two points among these 4 points could be maximized, right? And the minimum distance, if you see, then the minimum distance between any 2 points in case of maximizing it would come as side only, right? So and the minimum value for this any 2 points, because since all the points are unique, the minimum distance would be 1, right? This is the minimum value that is possible, and the maximum value that is possible is your side. So you have to find out the value in between two. But if you do my binary search, actually these values won't matter much. Just for the observation I'm telling you. So you have to find out for the mid value, that is max minus min by 2. every time you will check whether this mid distance, if you keep the distance mid, then are you able to select the k elements among these points or not, right? So to find out all these points, let me delete and rewrite it more clearly. We see this to calculate the Manhattan distance. So what is the Manhattan distance? This distance, this is the distance between these two, right? And if you, that is 2 here. And if you see the Manhattan distance, that is 2 minus 0 plus 0 minus 0. That is what written there, right? Yi minus yj. Since it is mod, it doesn't matter where you put it, but this is it. So I xj. And if you see between this distance between these 2 points, the Manhattan distance will come as 2 minus 0 mod plus 1 minus 0. This is 3. So this is actually a distance. If we flatten it out and we try to write it in this point on this number line, then this is the distance, right? This is 2, this distance is 2, and this distance is actually 1. And similarly, this point will fall on here, right? So this distance will come as 4. Do you see? And this distance is 2 plus 2 plus 2 minus this x value. So that will come as 5. But if you see, the Manhattan distance between these two is actually 3, right? But here we are considering it as 5. Why? Because if we put it on 3 again, then this is considered as overlap. So you would not get the actual value. So we have to write it in such a way that we can represent it in a number line. Also, when this point will repeat after if you complete a complete perimeter, right? So that is at 2 plus 2 plus 2 plus 2 at 0.8, right? Somewhere here, let's say there is a 0.8. So let me write it down again, the number line. This is 0, then 1, 2, 3, 4, 5, 6, 7, 8. And this point is again 0 point, right? This is not a separate point. So we were trying out for the mid distance. If that distance, if with that distance, if it is possible to select 4 points or not, right? So where we have points at 0, at 2 we have, then at 3 we have, and 4 we have, at 5 we have. That is it, right? So if we select this point, can we select this point with mid equal to, let's assume 2. So this is, we can select this. Can we select this? No, because this distance is 1. So we have to select this point. 3 points we could select. Can we select this 5th point? No, actually, because this distance is 1. So we can only select 3 points, right? So let's see, check if for mid equal to 1, we would decrease the higher upper bound to -1, and then see for 1, can we select 4 points? So if we select 0, then can we select this point? Yes, we can, but there is no point actually, right? But so we can select this point. So 2 points selected. Can we select this point? Yes, we can select this point. Can we select this point? Yes, we can select this point. So we see we have already selected 4 points. We don't need to check afterwards. So as soon as we see we can select 4 points, the answer for mid 1 equal to true. And we would, since 2 is not possible, 1 is possible. So we are going to return 1. So that is what our answer is. Right? Now there is one more catch here. So if even do we consider for the length 2, so let's assume there is a point also present here, that is at point 0 comma 1. And how we are going to represent it in this number line? At point, you see 2 plus 2 plus 2 plus 2 minus y length, that is 7, right? So at point 7, we would represent this point, right? And if we, I am changing this values, like for the second example, I'm considering this new point here, and to illustrate that whether we should even consider this point or not for a distance of 2, because for distance of 2, this distance is 1, right? Ideally, we should only consider till this point, all the points before this point. So there is no point as such, like this point you can consider, but not this point, right? So how we are going to calculate that, whether we have to consider this or not? So if we are starting at point 0, then where are we ending? Then we should end at end equal to start plus perimeter, that is, well, again the length where we are reaching, right? Perimeter minus how much distance we should decrease. So that is the same distance that we are calculating, right? We have to maintain this distance. So we would maintain, remove this element. Then we would get any point. So for point 2, so for mid equal to 2, the value, the end value should be equal to 0 plus 8 minus 2, because this distance is again 2, right? So this is 6. Then we know this will be represented at 6. You can consider it. You can try to put some more value and do a good observation here, because this is a very important point in this question. Till what points you can consider to select among the k points. Yeah, let's move to the code and I will walk you through like how we are doing solving it, right? So we are first converting all the points into a 1D array, these 2D points. So for y equal to 0, where y equal to 0 means uh, this plane, right? Y equal to 0 means this plane, mm, where the height will be 0. So what would be the distance? Since all the points are in on perimeter only, then the x would be the distance, right, from the origin. So that is our x point here. So for x equal to 0, it means the it's not moving rightward. So this line, okay. What would be the distance for this? So for any point, what would be the distance? So the distance would be 4 into side, that is the perimeter, minus the y distance, right? That is 4 into L. For 4L is the actually long, and side minus y. Similarly, if y is side, like this line, then what is the, for this point, what should we consider? That should be, this is 3 into L, 3 into side, and minus this x value of this, right? So that is what I have written here. And for the this line, it would be the side plus y, that is side plus y, right? And now I have sorted this result, because the point you are given are in random fashion. So we have sorted this array, and we are doing a binary search for each mid distance, and we are checking whether if it is possible to pick k points for this distance among the numbers or not. So iterating over the all points, and this is the end, what I was showing you here. End is the start plus 4 into L, that is 4 into side, that is perimeter, minus the limit. This is the mid value basically, which we are checking. This is the same mid value, and the current is the start, so where we are checking from. And among all the points, we can find out like if it is possible to get all 4 points or not. So if this loop completes and current, so this is the contradiction case, and if it is more than this, then we are directly returning true. And this lower bound is basically the index of the first element, because so when we select this, we have to find out what is the first element from the right side that is present that has a safe distance of mid. So this is what it is trying to find out. And whenever we find out, we try to minimize the higher side. So if there is more point on the left of the array or not. Yeah. So yeah, this is the code. Hope you liked the video and the solution. Yeah. We'll meet again in the next video.